So this video is on linear arithmetic sequences. Okay, and if you haven't done so already, it really is worth taking a look at a previous video that I have on finding the nth term at junior cert level. Just doing that little recap is going to be really valuable to you. So the reason this is a linear arithmetic sequence is because it is going up by the same amount each time. Okay, so that's why it's linear, because we've got the same change each time, and it's arithmetic because you're adding, or you could be subtracting for arithmetic, but in this case we are adding 3 each time, so you're plussing something each time, and it's the same thing that you're adding on every time. That's what makes it linear. Okay, so you're just getting used to that language, but similar to what you would have done at junior cycle, finding the nth term, the quick way we would do it is, if it's adding 3 each time, we know it starts 3n, and to get from 3 to 7 then we'd add on 4. So the nth term equals 3n plus 4. Now if you found that a little bit hard to follow, as I said, go back and look up that video. I have it very clearly explained in a lot more detail there. So what I want to do here now is, that's our quick way of finding the nth term, and I want to show you now another way of finding the nth term. And the reason I'm going to show you another way is because this second way is going to help us problem solve in a lot more of these complicated sequence questions, okay, in a way that this would limit us a little bit. So the second way, the good news is this is coming from a formula that is in your log tables. So in your log tables, you're giving a formula for the nth term as this. A plus n minus 1d. Now, what this stands for is, the A always stands for the first term, and the D stands for the common difference. Okay, so taking my example up here, the very first term has got to be 7. So A is 7, so I'm going to fill that in. So Tn equals, A I know in this case is 7, plus, keep your n, because you need n obviously in the rule or the nth term, minus 1, and d is the common difference. So the common difference here is 3. It's going up by 3 each time. So keep brackets around anything you sub in. So evaluating that then, that's being multiplied here to both the n and the minus 1, so be careful. So I end up with 7 plus 3 times n is 3n, and 3 times minus 1 is minus 3. And then you can add together your numbers. Of course, remember you're adding algebra. You can only add together things that are the same. There's no other n's to add together to 3n, so leave 3n as it is. And 7 take away 3 can be added together because they're both numbers. 7 take away 3 is 4. So there we go. We get the very same answer, 3n plus 4. But I want you to be able to use this formula because this is going to prove to be particularly useful now with some of the more complicated questions we're going to deal with. Okay, so here's a question for you. In an arithmetic sequence, T4 is equal to 14. In other words, the fourth term is 14. And T9 is equal to 34. Okay, in other words, the ninth term is 34. It's asking me to find the values of A and D and hence write down the value of T13. So find A and D and the 13th term. Okay, so here is one of those questions where our little formula that is in the log tables is going to prove very useful. All right. If you feel confident that you want to give this a go, press pause and see how you get on with it. Otherwise, watch me go through it now thoroughly and you'll be more prepared for the next example. So let's just sub in this information that I'm given here into this formula as best I can. So if it's talking about the fourth term, I know n is going to be 4. I don't know what A is at this point. Obviously, it's one of the things I need to find. So I may leave A as A for the moment. Plus, but I do know what N is. I know in this case, for this bit of information, T4 is equal to 14. My N is 4. So 4 take away 1. And the common difference, I don't yet know either. So I may leave that as D. But that gives me A plus 4 minus 1 is 3. D. And of course I know what T4 is equal to. It's here. The fourth term is 14, so I can put that in for the fourth term. I know then that 14 has got to be equal to A plus 3D. All right, now that's as far as I can go with that, but I do have another bit of information that I'm going to be able to sub in here as well. So subbing in 9 in this case for N, I get T9 is equal to A, I still don't know. The N, I know this case is 9, take away 1, and the D I still don't know either. So I left with A plus 8D, and I know T9 though is 34, so I'll put that in as my result. And now I get 34 equals A plus 8D. Now what I have here, I've got two equations now in A and D, so two equations, two unknowns. So in order to solve for this now, I will do simultaneous equations. So 14 equals A plus 3D, and 34 is equal to A plus 8D. And if you remember with your simultaneous equations, what I want to do is eliminate either the A's or the D's. Now it's quite nice here because the A's are already set up to be easily eliminated. In other words, I have the same amount of them, but obviously I need them to have different signs so that they will cancel. So what I'm going to do is I'm going to multiply the top line across by minus 1. Okay, so I can do that as long as I'm multiplying everything in the whole equation by minus 1. So what I end up with is minus 1 times 14 is minus 14, minus 1 times A is minus A, minus 1 times 3D is minus 3D, and the bottom line stays the same. And what I get then is minus 14 plus 34, which is 20. Minus A plus A is 0, which is what you want to have happen. You want them to eliminate. And minus 3D plus 8D is 5D. So now you have 20 equals 5D, and to get D on its own, we divide both sides by 5. So we get D is equal to 4. Okay, so we've solved the common difference now. So now I'm going to use that to sub back in, remember with your simultaneous equations, to one of the original. I'm going to take this one because it's just lower, easier numbers. So 14 equals A plus 3D, and I know D is equal to 4, so I'm going to sub that 4 in for the D now. So 14 is equal to A plus, and instead of 3 times D, I'm going to sub in 4, keep brackets around it, remember. So 3 times 4, which works out to be 12, and now to get A on its own, I'll take away 12 from both sides, so I get A is equal to 2. So there is the first couple of parts to this question. I was asked to find A and D, which I now have, and now I'm asked to find the 13th term. So the 13th term, well, let's see, go back to our nth term from our log tables up here. Do you remember that? And now I know exactly what I'm filling in for the A and exactly what I'm filling in for the D. So I'm going to be able to get the nth term, and we already know that once we have the nth term, we can find any term we want. So if A is equal to 2 and D is equal to 4, remember we're going to multiply this out, I'm going to be left with Tn is equal to 2 plus 4 times n is 4n. 4 times minus 1 is minus 4. And again, I can tidy up the numbers here. So Tn is equal to 4n, and 2 minus 4 is minus 2. So there's my nth term. And now I'm going to be able to use that quite nicely to find T13. T13 is going to be 4 times 13 minus 2, which works out to be 50. And there's my 3 answers. A is 2, D is 4, and the 13th term is 50. Okay, so try this question. If the 4th term is 11 and the 9th term is 21, find A, the first term, D, the common difference, and T50, in other words, the 50th term. Okay, pause the video here and see how you get on. So remember, from our log tables, we have A plus N minus 1D. Okay, so we're going to use that to fill in the information we're given as best we can. So if I'm talking about the 4th term here, I'm talking about T4. 4, in other words, is subbed in for N. So I don't know what A is yet. N, though, I can sub in 4, minus 1, and D I don't know yet, so I leave as D. So that gives me A plus 4 take away 1 is 3, D, and of course I know the 4th term is 11, so I can put that equal to 11. The 9th term, now we're changing N to 9, and I can sub that in, leaving the A and the D because I don't know them yet, and I'm getting A plus 8D, and of course I know the 9th term results in 21, so I fill that in also. So now you have 2 unknowns and 2 equations, so we're going to do simultaneous equations. So I have 11 equals A plus 3D and 21 equals A plus 8D, and I want to eliminate either the A's or the D's. The A's are set up quite nicely again because I've got the same amount of each, but I need one to be a plus and one to be a minus, so they actually cancel each other out. So I'm going to multiply that whole top line by minus 1. And when I do that, I get minus 1 times 11 is minus 11, minus 1 times A is minus A, and minus 1 times 3D is minus 3D. And the bottom line stays the same, 21 equals A plus 8D. And now I'm going to just add these together. So I end up with minus 11 plus 21 is 10. Minus A plus A is 0. Nothing, in other words, so they're gone, which is exactly what I want to have happen. And minus 3D plus 8D is 5D. So if 10 is equal to 5D, divide both sides by 5, and I get D is equal to 2. Okay, let's take that answer and sub it back into one of my originals. I'm going to go with the easier one, A plus 11 equals A plus 3D, and of course my D is equal to 2, so I'm going to sub that in. So 11 equals A plus 3 times 2, so that's 11 equals A plus 6. Take away 6 then to both sides to get A on its own, and I'm left with 5. So A is equal to 5. So now I want T50. So let's first of all get it back into my formula. Tn is equal to A plus N minus 1D. So now to get the nth term, I can sub in for A and sub in for D, which is 2. Remember, you're going to multiply the 2 by the n and the minus 1. So Tn is equal to 5 plus 2 times n is 2n. 2 times minus 1 is minus 2. Add your numbers together. 5 take away 2 will give me 2n plus 3. So now I've got my nth term. It's going to be really easy to find any term I want. I'm looking in this question for T50. So subbing in 50. I'm getting 2 times 50 is 100, plus 3 is 103. And that's my answer. Okay, so take a look at this question. It's a little bit more complicated, but why don't you pause the video and see how far you can get with it. So I'm going to start, as always, with writing out what I have in my log tables. Tn equals A plus N minus 1D. And I'm going to just fill in the information I'm given as best I can. Now, take this, right? We'll do this bit by bit. Term 1 Well, term 1 is just going to be A plus 1 minus 1, which is 0, times D, which is obviously 0. Well, it makes sense. Term 1 is obviously just A on its own. A is always the first term. So that's the first term, A, or T1. And T5, subbing into this, would be A plus, instead of N, I have 5 minus 1, D. So T5 is equal to A plus 4D. Okay, so now what this information here is telling me is the term 1 added to term 5 is 0. Well, term 1 is A, added to term 5, the expression I have for term 5, which is A plus 4D, is equal to 0. So term 1, A, added to term 5, A plus 4D, is equal to 0. So that's that information written out in A and D, which is what I want. I'm tidying that up. Remember, with your algebra, you can add together things that are the same. So A plus A is 2A plus 4D is equal to 0. Right, there's your first equation. We're going to get our next equation from this bit of information. T13 is equal to 20. So again, let's sub that as best we can into here. We get that N is 13. A, of course, we don't know. Plus 13 take away 1. D, we don't know. That gives me A plus 12D. And I know that 13th term is 20. So put it equal to 20. So there we go. There is our other equation in A and D. So I'm going to use these two equations now and solve them simultaneously to find A and D. So I have 2A plus 4D is equal to 0. And I'm just going to rewrite this now. So I'm putting the A's under the A's, the D's under the D's, and the numbers under the numbers. So I'll put A here, 12D here, and 20 here. So I haven't got the same amount of A's here, but it is going to be easier to eliminate the A's than the D's. If I have 2A here, ideally what I want to have here is minus 2A. That would make them cancel. So what I'm going to do is I'm going to multiply that second line by minus 2. So the top line stays the same. And the bottom line gets multiplied by minus 2. So minus 2 times A is minus 2A. Minus 2 times 12D is minus 24D. And minus 2 times 20 is minus 40. Okay? So adding them together, 2A minus 2A is 0, which is exactly what I want to have happen. 4D minus 24D is minus 20D, and 0 minus 40 is minus 40. To get D on its own, I want to get rid of this minus 20 that's being multiplied. So I will do the opposite. I will divide by minus 20. So divide that side by minus 20 and I get D on its own. And divide minus 40 by minus 20, I get a positive 2. So there is D. D is equal to 2. So I'm going to take that now and sub it back into one of my originals. I'll just go with the top one here. 2A plus 4D equals 0. And of course, D is equal to 2. So I'm going to sub that in. Instead of D, I'm putting brackets around it, of course. Subbing in 2 for D is equal to 0. That gives me 4 times 2 is 8. I'll take away 8 from both sides and I leave the 2A on the left hand side, and 0 minus 8 is minus 8. And now to get A on its own, I divide both sides by 2. So I'm left with A is equal to minus 8 divided by 2 is minus 4. Okay, so A is equal to minus 4. So we have our A and we have our D, which was the first part of the question. The second part of the question, I'm just going to write it out here again for ourselves. It asked me to show that T7 is equal to twice T5. Okay, so T7 is equal to twice T5. Right, well, let's first of all try and work out what T7 is. So again, going back to our formula for the nth term. This time, there's lots of bit of information I know. I know A, and in this case, if I'm looking at T7, I know what N is, and I know what D is as well. So let's consider T7. A, I know, is minus 4. N, in this case, is 7, minus 1. And D, we know now, is 2. Put brackets around it. So what am I getting? So I'm getting now T7 is minus 4 plus 7 take away 1 is 6. 6 times 2. So 6 times 2 is 12. 12 take away 4, or minus 4 plus 12, is 8. So T7, I know, is equal to 8. All right. Now let's have a look at T5. Okay, let's just have a look at T5. I want to show that T7 is twice T5, but let's just take a look and see what T5 is first. So T5, so I'm going to do the same thing as I did over here for T7, filling all the bits of information that I know. I know A is minus 4, plus N in this case is 5, take away 1, and D, I know, of course, is 2. So T5 is equal to minus 4 plus 4 times 2, which is 8. So minus 4 plus 8 is 4. So back to what it's asking me. T7 is equal to 2 times T5. Is 8 equals to 2 times T5? In other words, is 8 equals to 2 times 4? Is T7 is equal to 2 times T5? And of course, it is. So last element to linear arithmetic sequences I want to just cover in this video is if you're asked the following question. If x plus 1, 2x minus 2, and 2x plus 1, if these are 3 terms in an arithmetic sequence, then find the value of x. Okay, so these are 3 terms in an arithmetic sequence. Find the value of x. Well, what can I work with here? The only piece of information they're really telling me is it's an arithmetic sequence. And right back at the start of this video, I explained what an arithmetic sequence was. An arithmetic sequence means that you're adding on the same common difference each time. So whatever I'm adding on to this to get this, I'm adding the same thing on this to get this. So let's just take a look at just a number example here first to see what's going on. And that might help us get our heads around dealing with terms that involve x's. So let's take 3, 5, 7, which would be 3 terms in an arithmetic sequence. Obviously you're adding on 2 each time. Well, one way we could look at this, because this is the only bit of information I know, that is that there's a common difference. If I do have the 3 terms that are in order in an arithmetic sequence, I know that 5 take away 3 is going to equal 7 take away 5. So that's the same idea I'm going to take with these. I don't know exactly what the common difference is here, but I do know that the difference between these two and these two have to be the same. So just like I did for this, I'm going to do for this. So what will that give me? So in other words, this subtract this, so 2x minus 2 subtract x plus 1 must equate to this subtract this. So 2x plus 1 subtract 2x minus 2. So now what we have here, you see, is an equation with one unknown, which means I'm going to be able to solve for this x. So just be careful here, because when I subtract the x and subtract the 1, that minus, it's like multiplying by a minus 1, is going to have an effect on all the signs in here. So you're subtracting the x, so minus x and minus 1. and you have 2x plus 1, and same thing here, you're subtracting the 2x, and when you subtract a negative 2, you end up with minus minus 2, and minus minus, or subtracting a negative, is like adding, so that changes to add 2. Okay, so then going a bit further, we can tidy up and add our x's with our x's. So 2x take away x is x, and our numbers with our numbers. Minus 2 minus 1 is minus 3. That's tidying up everything on the left hand side. I'm going to do the same on the right hand side, the x's with the x's. 2x take away 2x, well, that's nothing. And plus 1 plus 2 is 3. So now we're left with this nice simple equation, and to get x on its own, I'm going to get rid of the minus 3 by adding 3 to both sides, and then I get x is equal to 6. And there's my answer. So try this question. P plus 2, 2p plus 3, and 5p minus 2 are 3 consecutive terms of an arithmetic sequence. So there are 3 terms in order in an arithmetic sequence. Find the value of p. Pause the video, see how you get on with this. So just like before, I know that they have the same common difference, although I don't know what that common difference is. I know that that subtract that will equal the difference, and that subtract that will equal the difference. So those two things will equal each other. So 2p plus 3 subtract p plus 2, so that term minus its term previous is equal to this term take away its previous term. Keep it in brackets first, because that minus is going to affect all the signs here and here, so be careful. So I'm left with 2p plus 3, then take away the p and take away the 2. And 5p minus 2, take away 2p and take away that 3. So we can tidy up and add our p's together. 2p minus p is p. 3 take away 2 is 1. And on the right hand side, tidying it up, 5p take away 2p is 3p, and minus 2 minus 3 is minus 5. Okay, tidying up this equation then, I can't have p's on both sides, so I'll take away this p from the left hand side, and I've got to do the same on the right hand side, of course, and then I'm left with, and then add 5 to both sides. I'm left with 2p equals 6, and to get p on its own, divide by 2 on the left hand side, on the right hand side actually, p, and then I must divide by 2 then on the other side, the left hand side. So p is equal to 3.